This episode is brought to you by the Field Museum in Chicago, Illinois, and the Museum for Naturkunde in Berlin, Germany. Arachnids do not typically make it onto people's top list for favorite animals, which is too bad. There's so much diversity, from camel spiders and scorpions to, well, regular spiders. We just can't get enough of these amazing creatures. And lucky for us, at the Museum for Naturkunde in Berlin, we were able to chat with another arachnologist, Dr. Jason Dunlop. He's the senior curator for arachnids and myriapods, and his focus is on fossil arachnids.
What really fascinates me is the idea of where did spiders and other arachnids evolve from? And so what I do is try and use the fossil record to try and answer some of these questions about how do these different groups relate to each other? Do we find anything like a sort of missing link between two groups of arachnids?
What makes fossil arachnids so wonderful to study is that most of Jason's specimens are encased in amber, sort of like, Jurassic Park. And it means that many of their features are immaculately preserved, which recently led Jason and his colleagues to a rather large discovery.
I understand that you became quite the media sensation with a publication that you had pretty recently.
Well, what happened was a few years ago we discovered a new harvestman in amber. This was back in 2005. And we had a sort of suspicion that it might be something new, something we don't have today, but we couldn't really prove it. Because one of the things about taxonomy of spiders and harvestmen and other arachnids is very often you need the genitalia. And then a few years later, a colleague of mine phoned me up and said, well, hang on, I've got one where I think I can see the genitalia, and then the male of this harvestman has a so-called penis, and he could see it actually stuck out of the body, which we couldn't see in the original specimen. And it's very, very rare to see this in an amber harvestman. And so we got sent the specimen, we wrote it up and we published this. And of course we had a suspicion that this could be a bit of a newsworthy story. So of course we sent out a press release, and we got quite a lot of feedback from that. And people sort of really jumped on this idea that they'd found this 100 million year old penis in amber, and this became really quite a sensation.
So how does this make you feel as like a scientist, as a taxonomist, whose work, no offense, probably isn't going to make headlines very often?
On the one side, we're very happy when people like National Geographic write a serious article about it, and it does have a serious side because we could use these characters that we saw to say that this is a new family, an extinct family. It's something really quite different, and we could actually put it into the tree of life, as it were, thanks to this penis that we found. Of course, on the other hand, it also means that we come into the tabloid press and lots of very silly stories. At least it gets people thinking about the subject. It gets people perhaps interested in the fact that there are these fossil arachnids, and that you can actually find remarkable stories about them.
Is there actually a pretty wide variety of organisms that are preserved in amber in that way?
Basically, anything that could get itself caught in tree resin has a good chance of being preserved in amber. So it's very rare to get something like a lizard or a bird. It's much more common to find an arachnid or an insect. The nice thing, of course, is they're extremely well preserved, and you can study all the details that you can see on a modern one. There's also new techniques that we can use called computer tomography, where you can really make a wonderful dry three-dimensional scan of the specimen and really study it as though it was as a living spider.
So how old are spiders? Do you have an estimate for when they first appeared in the fossil record?
The oldest spider that we know of is about 315 million years old. So that comes from the Carboniferous period. And we're pretty sure they belong to a primitive group of spiders that are still alive today. The group in Southeast Asia, they're called the mesothelials. Most spiders don't have any segmentation, but these spiders still have this primitive character of plates on the back of the abdomen. And we've actually got a very nice example here. This is quite a large spider here, which I'm actually going to be working on very shortly. And this is about 99 million years old. So it means this spider would have been running around under the feet of the dinosaurs. It's an extremely well preserved male spider. We can tell that because of what we found, these little organs called the palp organs. At the front of the body. And what's interesting here is that it seems to be one of these segmented spiders, but the position of the spinnerets where the silk would have come out is a little bit different to what we would see in a modern spider. So this is why this specimen is going to be quite an interesting example to look at.
How many extinct spider species do we know of?
Well, there's about 1,300 extinct species of spider. With fossils, you're always looking at, like we say, windows into space and time. So most fossil spiders are known from Baltic amber, which is found here in Europe. Just because we've been looking at it for 200 years, there's now a new amber coming in Southeast Asia, which we've only known about really intensively the last few years. And it may be that in the future we'll have a lot more data from this particular source.
I saw that you're involved in a project called the World Spider Catalog. It seems to be this amazing global collaborative effort to catalog all of the world's spiders. Where did this initiative come from? And I mean, how many spiders are we actually talking about here?
Well, we're talking at about 47,000 living spiders. And the project goes back to the 1950s when a French guy called Pierre Bonnet actually started sitting down and typing all of this data in. And of course, we've taken that basic data and turned this now into a computer database. And this means that we can know exactly how many species of spiders are described, where they're found, and where they've been mentioned in the scientific literature. And this is extremely helpful for people working on describing new species, because at least you have a starting point, you have a baseline and say, okay, for this group of spiders, this is what we know, and I can describe new ones. And then of course that data gets fed into the catalogue, and we have a much more accurate picture of how many spiders there are in the world and where we can find them.
How many people study fossil spiders?
Not very many, to be honest. There's perhaps about a dozen people worldwide who are actively looking at fossil spiders or other arachnids. So it's a fairly restricted group. And of course, we all know each other and have a good idea of who's doing what. And we sort of help each other out.
I mean, I get excited when I think about the fact that that was living around the dinosaurs, you know, like they were coinciding at the same time. And yet, I mean, there are all these books about dinosaurs for children, but I don't know of any about fossil spiders.
No, I mean, I wrote a book on fossil spiders, but not for children, unfortunately. But there is, they're not as familiar to people, perhaps, as fossil groups like dinosaurs or trilobites. Yeah. So, I mean, one of the things I've always been trying to push in my career and going to conferences and saying, hey, guys, there are actually nearly 2,000 fossil species of arachnids as well. They're actually really quite an important group, and they're worth studying for understanding where these animals came from.
I think that's a good message for our viewers at home, staring at the viewers now. It's like, study fossil spiders. It still has brains on it.